Guys, Mr. Catlin here. We're looking at some practice problems. We're starting with problem number 1 from 1.4. And we've got ourselves a little polygon that has several different angle sizes. 6 sides. We're calling this polygon P. And the copy that we're going to make is Q. But as you can see, we have P here. And this is going to be true statements for a scaled copy. Any scaled copy. So same size, larger, smaller, as long as it's scaled, these are things that will be true. Okay, so we're only going to pick the true ones. So let's start here. The side lengths are all whole numbers. Well, in a perfect world where it's all rainbows and butterflies and things are all pretty and nice and sugar and spice, yes, we would have all the numbers be whole. But we live in a complex world with complex numbers, and we can't just always have whole stuff. And when you scale things, you have some weird numbers come out. We've seen that in some of the problems that we've done. So we are not going to pick that. There's no way we can guarantee that all of the side lengths are going to be whole. There's no way. Angle measures are all whole numbers. This one we can be specific on because we know all of the angle measures. 80, 250, 35, 1. We know them all. That's a 90, even though it's not written. We know it from the symbol and the notation. So, since we know that they are all going to be whole numbers to start, and that all scaled copies angles never change, we can guarantee that that will be true on any scaled copy of this. Now, Q, which is the one that we're going to draw, has exactly one right angle. Well, our original has exactly one right angle. So the scale copy of it would too, since the angles do not change. And if the scale factor between P and Q is a fifth, so everything gets cut down a fifth of the size. So for example, if this was 20, we would divide that by 5, and the new one would become a 4. Alright, so if that's taking place, then each side length of P is multiplied by 1/5 to get the corresponding side. It's exactly what we do. We would multiply, in this case, if that was 20, we'd multiply it by 1/5, and we would get the answer for the corresponding side of the new shape, which is 4. So that is a true statement. If 1/5 is the scale factor between P and Q, we would multiply all of these by 1/5 to get the new ones. That's a true statement. If the scale factor is 2, each angle is multiplied by... angles don't get multiplied when you scale things. They stay the same. So that's like a dead giveaway right there. If you see angle is twice, or angle is tripled, or angle is multiplied, no, that's not going to take place. For these reasons up here, the angles stay the same. F. Q has 2 acute angles and 3 obtuse. Well, let's see. There are 1, 2, 3, 4, 5. There are 6 angles altogether. So let's see. One of them is right, so that's probably why we're dealing with 5 here. Are 2 of them acute? It looks like we have an acute here at 35 and 80. So I like that. And then 3 obtuse, greater than 90. That would be here, and here, and here. So that is true. Although, I might want to double check that. I always thought obtuse was between 90 and 180. I might have to get back and check that one. But I'm going to select it as true for right now. Those angles are going to stay the same, and that's 2 that are less than 90 and 3 that are greater than 90. So there you go. Help with problem number 1.